to all the co-authors is it just these and the tremendous group at ASU that processes this beautiful LROC data set and brings it to you. We're going to be talking about primarily images taken for geometric stereo in South Pole-Aitken Basin, and this is going to continue a discussion we had yesterday at the SPA focus group. And a number of the LROC folks are here. In addition to Mark Robinson, the PI, just also point out one name that's not on here, Kyle Burns, who really does fantastic work in producing DTMs from geometric stereo images. We'll talk a little bit more about that. So just some background. For the exploration phase of LRO, NASA had designated a number of constellation sites. Remember constellation? There are about 10 of these sites in and around South Pole-Aitken Basin. So we have tremendous coverage there, including geometric stereo. Some of those sites include an SPA interior site near the very middle of the basin, a rim site actually near the transient crater rim, if you can guess where the transient crater cavity was, Apollo Basin, Van de Graaff crater, Mare Ingeni, Schrodinger Basin. And then there are also constellation sites at Aitken Crater at the South Pole and at Malapert Massif. So quite a bit of good coverage in and around SPA. The extended science mission, which we're just coming into and we've just proposed for the extended science mission, has an elliptical orbit, and that orbit is good for the southern hemisphere and high-resolution imaging there. And especially for high-resolution geometric stereo analysis. So one of the things we want to do here is to actually get some community input to what some of those very special targets ought to be. And so that's what this is about. Okay, South Pole-Aitken Basin itself scientifically is one of the richest target areas on the moon. It's a major unsampled terrain. We don't have ground truth there. Wonderful remote sensing, but no ground truth yet. And if we have lunar meteorites from this area, it's difficult to confirm at this point. So what are the materials of the lower crust and upper mantle of the moon that may have been exposed and excavated here? How did the moon differentiate? These are questions we can address in this region. Does the moon record an early cataclysmic bombardment in the solar system? This is as far away from the Imbrium Procellarum region as you can get, and so this offers answers to some of these questions. And this has been identified again as a high priority for solar system exploration in the most recent decadal survey, in addition to the one over 10 years ago. Again, major science questions. SPA represents an enormous impact, megabasin. How deep did it go? Hundreds of kilometers? Did it excavate mantle and mix in mantle materials? What were the impact parameters? What's the composition of the melt? What are the clast contents? And did this impact melt complex differentiate? What can we tell about it? So lots of questions that we can address here. And just in looking at the effects of SPA on the early crust moon wide, this is a very, very simple just stratigraphic sort of section here. But one of the things that remote sensing is showing us is that there's an anorthositic layer, but it looks like it's buried. It's actually not the very uppermost crust. The uppermost crust is this megaregolith, lower crust perhaps more mafic, but this megaregolith is likely produced by a number of large basin impacts, and SPA may have been the major contributor moon-wide, especially on the far side, northern far side, to this megaregolith. Far side basalts. There are a number of basalts exposed within SPA, and of course this would be one of the targets. There are pyroclastic deposits as well. The thorium distribution. This is a view kind of rotated up a little bit so that you can center on SPA. There are a couple of large anomalies in here that are exposed by impact craters. And then there's this general background. What is this, and what are the implications for thermal evolution of the moon? Iron distribution. Here shows the iron anomaly. How much of this is from the lower crust? How much of this might represent mantle infilling? How much of it is contributed by ancient Mare basalts that are now covered? So again, lots of unknowns here. In terms of just summarizing these science themes, so again, we have basin chronology and bombardment history, composition mineralogy of the lunar interior, lower crust and upper mantle, and the crustal dichotomy. We can get at this. Far side basalts, including cryptomare, that's what's shown here in blue, cryptomare, intrabasin plains deposits, thorium and creep distribution, and magnetic anomalies, which we heard about earlier in this conference. Okay, let's talk about the NAC coverage. What you should get from this is that there is a tremendous amount of NAC coverage now. If you zoom in on these areas, you see that there are indeed some gaps. So we still have to fill some gaps, and this is just showing the same area here without the cover. But when we look at geometric stereo, whoa, that's a whole lot less data. So geometric stereo are very special observations. And just to show you kind of where those are located now here on topography, you can see we have a number of sites in the interior, rim site, and then some others in basins and craters surrounding, and even down to the South Pole here. Okay, so that's the geometric stereo coverage. Just a word about geometric stereo. So as you know, the NACs comprise two parallel strips, but those don't really overlap, so that's not where we get the stereo. We get the stereo by slewing the spacecraft on a subsequent orbit, so we have one nadir look, a slew, and from those two images of the same territory, we can get a geometric stereo image. So these are expensive. In the extended science mission, we may have something like 4 months each year with illumination suitable for geometric stereo, and of course it varies as a function of latitude. So, 48 pairs in SPA in a year, that's about it. So we have to target these very carefully. And of course, latitude does make a difference, and we have to give careful consideration to that as well. So in some, NAC stereo images require a lot of resources. In terms of NAC DTMs, you can find these now on the web. The LROC website actually has a number of these that have been produced by the ASU crowd. The LMMP has a number of these that have been produced by USGS, University of Arizona, as well as ASU and others. And there are some other websites and some references here to how these images are produced. Okay, just looking, now I'm going to go quickly through some of the locations where we have stereo. This is in the interior of the basin, and we have a number of sites here that are located. This is almost the geometric center of the basin. Some interesting features in here, as well as the South Pole-Aitken interior constellation site, which is very, very well covered. And we'll just zoom in on this. I apologize, we'll go through quickly with these just to give you an idea of where these are. This is one of these constellation sites, and this shows a 40-kilometer box, a 20-kilometer, and a 10-kilometer box. And this is meant to select a representative area in the interior of the basin and really show what that topography is like. So that's the coverage for geometric stereo, and that's what the DTM looks like. So here's topography, here are slopes. These are fantastic images. This is several gigabytes of data here, so you can really get into this and see every little crater and even resolve some of the larger boulders. And then this is from Brent Arkinel's abstract I think a year ago, discusses putting together the huge mosaic, and then this is the available DTM. This is the rim site. Again, a very nice collection. This is actually 1, 2, 3 or more individual DTMs that have been put together. This was done by the group at ASU. And again, quickly, Baba East, this is one site. This is just a single DTM in this case. This actually is very good for landing site analysis and assessment if you want to look at hazards, but also very good for doing things like analyzing the topography right at the surface and understanding what the cryptomare might be. The plains deposits that underlie these relatively flat-lying areas, in many of these cases, look like thin mare basalts. Again, landing site analysis, this just shows an example of the information here. This is just stretched at 3 different levels, and you can see the information here in a place where you might be interested in landing. You can get tremendous information about slopes and hazards. Looking now at some of the other coverage, this is Mare Ingeni and a couple of other locations, Van de Graaff crater here. This is, again, an area where we have a constellation site and a number of DTMs that have been produced, so you can see the tremendous amount of data here. Apollo Basin and Oppenheimer, so here's a location within Apollo. Over here in Oppenheimer, there's a dark halo deposit and Oppenheimer U crater. These are interesting places in their own right. Schrodinger Basin, this of course is a very interesting chart, very low latitude. So this is 75 degrees south. These are difficult to make, but we have a number of good observations in here. An observation over in the Peak Ring in Graben. Okay, I'll ramp it up to 0.75 Botkeys. Antoniadi Crater. This is a pretty neat one. This is a beautiful, beautiful crater, deepest point on the moon. This, by the way, I've been just kind of skimming over some of these. The WAC GLD 100 is also a beautiful data set and complements Lola quite nicely, and we use it extensively for context. But here you can see a couple of NAC DTMs covering this particular spot. Okay, so just to this is actually the conclusion here. The idea is that with continued imaging in the extended science mission, we will fill NAC gaps in key areas. We'll get some repeat imaging in areas where we would like to have different illumination conditions. And we'll work on geometric stereo for key targets. So what we're trying to do is get science community input into these. For the geometric stereo image requests, as we discussed yesterday, please contact Noah Petro, and actually we're putting together sort of a short white papers with rationale and location to describe those sites. So we'll include the site coordinates, perhaps a WAC base image just to show the extents and the exact latitude and longitude so we can get this right, and we'll get these worked into the targeting queue. So as soon as possible, LRO is currently in a very good illumination situation for geometric stereo and SPA Basin. So now is good, and if you can get us information at least no later than the league meeting, then we can start to work these in for future observation campaigns. So thank you.
Questions?
Perhaps all the questions were asked yesterday.
So is there a preferred size of feature you want people to?
It's actually a very good question, and thank you for bringing that up. Just as a reminder, for those of you who haven't worked with the NAC images, they're really small areas. So an individual frame is 2.5 at this nominal resolution, on order of 2.5 kilometers by, say, 25 kilometers, and two of those together is 5 kilometers wide. So they don't cover a whole lot of territory. So a request to image, an entire 100-kilometer crater that's not going to happen for geometric stereo. But if you're targeting, if you're saying, well, let's plan a landing site that is advantageous for that crater, then one frame in the right location where you might design a traverse, something like that would be